Okay, so questions for science. So in this piece, what we're going to look at are questions that are suitable for science, and then how scientists go about putting together questions, and then how they go about answering those questions. And that's essentially fundamentally what science is all about. So in this section, we're going to be looking at, by the end of it, students should be able to recognize questions that are appropriate for scientific investigations. So not all questions are suitable for science. Some questions, it's outside the realm of science if you like to be able to answer the questions. To pose testable hypothesis. So how do you go about taking a question, turn it into a hypothesis, and then how do you go about being able to test it? And evaluate and compare strategies for investigating hypotheses. So that's essentially what we're going to look at in this section. So science really starts from curiosity. So if we think of a well-known scientist, so for example, Albert Einstein. So Albert Einstein was a very curious individual. And what does that mean? He wondered about things. He looked about in his environment, and he asked questions about how things work. And not only did he kind of ask questions, he thought about these things deeply as well. So Albert Einstein, he's a German-born and Einstein is considered the most influential physicist of the 20th century. So he came up with some very influential observations and theories in relation to physics. Among his many achievements were developing special and general theories of relativity and a Nobel Prize for Physics for his explanation of the photoelectric effect. So he famously said, "I have no special talents, I am only passionately curious." So Albert Einstein was a very curious individual, and he was genuinely deeply interested in the environment that was around him, and he that curiosity leads to asking questions. So in the context of Albert Einstein, what was he interested in? Well, he was wondering about things. So the things, for example, that are in his environment, we call these phenomenon. So if there's things that we observe in our environment, we use this word, what's known as a phenomenon. So for example, if we look out and we see that the grass is green, that is an observable phenomenon. So science then really starts with questions. So for example, one type of a question that we could ask: does the amount of time I spend studying maths improve my understanding of maths? So think about that question for a sec. So this is a question, and this is a question that we can go about and we can investigate and we can actually study and we can put together some way at investigating and answering this particular question. So when we think about and find out as much as we can about the potential answer, so for example, you might have an answer straight away off the top of your head in relation to this, but when you go about and you research it and you come up with a potential answer and then suggest an answer, we call this a prediction. So for example, you can come up with a question like this question here. When you think about what the answer is to that question, now generally when you ask a question, you're not going to be 100% about what the answer is, but you can make what's known as a prediction or an educated guess. So for example, when we think about what's the likely outcome to the answer going to be. Now if that prediction can be tested, so if we can actually go and we can carry out a test and find out whether our prediction is correct, then if we can test our prediction, it's called a hypothesis. Okay, so prediction, and then you have a hypothesis if you can go about and you can actually you can test your prediction. So for example, if you lose your phone, you might ask the question, where did I lose my phone? You might make a prediction and say that I lost it, I think I left it in the kitchen. So you can then, that's a hypothesis, you can go and test that out. So you can go into the kitchen, you can check and see, okay, there's my phone. So you can determine whether your prediction or your hypothesis is true or false. So that's what's very important in relation to scientific questions. So scientific questions are questions that a prediction can be made about the answer. you can determine a hypothesis, and you can go about and test and find out whether your predictions are correct or not. So what is a hypothesis then? The definition. So a hypothesis is a testable explanation for something we observe or notice. So when we create a hypothesis, we can use what's known as an if-then statement. So this is an example. So this question up here, it's very general. Okay, we can make a prediction about it. We can say yes, my understanding of maths will improve the more time I spend on it. And what we can do then is we can be very specific, and we can use what's known as an if-then statement. So if I study maths for 30 minutes every evening, then my grade in my maths test will improve. So this is something that's testable. And this is what's known as an if-then statement. So when you're being asked to create a hypothesis, you want to put it in the form of an if-then statement. So you want to take your general question and you want to boil it down into a very specific question. So this is something then that you could do. So for example, if you have a test coming up in a week's time, you could study 30 minutes every evening and see how you got on in your maths test, see if it improved from your last test, from the grade that you got in your last test. So it's something that you can come up with a way at testing your hypothesis. And this is saying, if I study maths for 30 minutes every evening, then my grade in my maths test will improve. So if you do this, study for 30 minutes every evening, you go and you do your test, and your grade is better than your previous test, then you can say that your hypothesis is true. Okay, if you do this 30 minutes every evening and you study and your result actually it gets worse, then you can say your hypothesis is false. So hypothesis is a testable explanation for something we observe or notice. So again, this can be completely testable. And that's what makes this a suitable question, if you like, for science, because it can be turned into, you can make a prediction about it, you can develop a hypothesis, you can then come up with a way to test your hypothesis. So you can actually develop an experiment or an investigation, or come up with a strategy to see if you're correct or not. And then you can turn it into an if-then statement and go ahead and test your hypothesis and determine whether it's true or it's false. So in other words, your question is testable, or your prediction, should I say, is testable. So questions suitable for scientific investigation. So just take a minute to have a look at this table here. So on the left-hand side, we have questions that are suitable for scientific investigation. And on the right-hand side, we have questions that are not suitable for scientific investigation. So I want you to kind of look at these, pause the video, look at each one and think about, like, why is it suitable or why is it not suitable for scientific investigation? So to determine if a question is suitable for scientific investigation, we need to ask, is the question testable? So can we test the question? And can I come up with a way to investigate to see if the question is answerable? So for example, can I put it into an if-then statement, and then can I go about and test it? So if we have a look at the first question, does adding salt to water affect the temperature at which it boils? So we can come up with an if-then statement. If I add salt to water, then the temperature at which it boils will decrease or lower. So I can turn this into an if-then statement. You can imagine how you could go about testing this. So you can see that it can be turned into a testable question. Now, if we compare this to a question that's not so science, we can use science to go about and answer this question. If we take a question then that's not suitable, so for example, what happens to us after we die? So this is something that it's very hard to test. Well, you can't test it scientifically. How would you go about measuring it? How would you go about it's a mystery. So it is like, what happens after we die? So therefore, this wouldn't be, as we can make speculations about what happens, but in the realm of science, we can't physically test this. So therefore, this would not be a question that's suitable for scientific investigation. So does the temperature affect the growth of mold on a piece of bread? So again, this is something we can turn it into an if-then statement, and we can go about and we can actually investigate it. So it's actually testable. Who, if anyone, pulls the strings of our universe? So again, does God exist? This is something that we cannot test at the moment. It's something that wouldn't be suitable, if you like, for scientific investigation. Does studying for an exam improve your result in an exam? So again, this is a question that we can turn it into an if-then statement. We can make a prediction, come up with a hypothesis, come up with an investigation, carry out the investigation, and then answer the question. So what is better, cheese and onion or salt and vinegar crisps? So again, this is something that you could go out and do a survey, but again, that survey is subjective. It's based on people's opinion or taste. So it's not something, so you can't really say, like when we say better, what do we mean by better? So again, it's too subjective, if you like, for science to take it on and investigate it. So what animals and plants are in the pond out the back of my house? So if you have a pond out the back of your house, for example, this is something that you can actually physically go and you can test and you can see what type of animals are in the pond. Which animal or plant in the pond is the scariest? So again, this is something that you could do a survey, but again, it's something that's subjective. There's nothing kind of concrete that you can test. It's just something that people can give their opinions about it. So you can survey it, but you can't really go about and test it. So what weight is my pencil case? So again, this is very testable. You can turn it into an if-then statement. You can come up with a hypothesis and you can test it. Is my pencil case a good-looking pencil case? So again, this is something that's completely subjective, and it wouldn't be something that would be suitable for scientific investigation. You can survey people's opinion, but again, it's not something that would be, if you like, suitable for to turn it into a scientific hypothesis and go about and test it. So let's think about then how we go about actually coming up with taking a question, turning it into a hypothesis, and then how do we go about and investigate it. So this is investigating a hypothesis. So a hypothesis, so again, we can take a question and we can turn it into an if-then statement. So these are two examples of hypotheses. If I study maths for 30 minutes every evening, then my grade in my maths test will improve. Okay, so this is it's a question, it's a prediction that we can go about and we can test. If I train before my race, then I will improve my race time. So again, this is something that you can implement, you can test, and you can get an answer for. So this involves coming up with a way to investigate your hypothesis, your strategy, gather data, and determine if your hypothesis is true or false. So that's what it means when we talk about investigating your hypothesis or testing out your predictions. This is what we're doing. So it involves coming up with a way to investigate your hypothesis. So coming up with a strategy. It means then going and actually carrying out your test, gathering your data, and then you're analysing your data and determining whether your prediction is true or false. So again, there's a lot of skill involved in this piece here in relation to taking a question, turn it into an if-then statement, coming up with a way to carry out a test to see if your prediction is true or false. So there's a lot of skill involved in that, and it's a huge piece of work that scientists do all the time. So they're trying to test, they're making observations in nature, for example, or whatever area of science they're studying, and they need to be able to take that question and determine how they're going to go about trying to get an answer to that question, seeing if their prediction or their hypothesis is true or false. So when planning an investigation or when coming up with your strategy to investigate your hypothesis, so these are some of the kind of things that you need to take into account. And we look at an example of this, and then I'm going to get you to actually go about, take a question, turn it into an if-then statement, and develop a procedure for carrying out the investigation. So you want to have a title, and then you want to have your hypothesis. So you have to take your question and turn it into an if-then statement. Then you need to think about, okay, so once you have your if-then statement, you need to think about what materials and equipment are you going to need in order to go about and investigate your hypothesis. It's always a good idea then as well is to come up with a procedure. So the actual steps that you're going to carry out, and number them 1, 2, 3, 4, 5. And sometimes as well, it's a good idea to do a labeled sketch of the steps as well. So for example, like a comic book, you have the step by step by step. a label diagram of that. Okay, so this is just a good way to show how you're going to go about carrying out the investigation. When you carry out the investigation, you're going to be recording something, or you're going to be measuring something. So you need to have a table to record your results. So you need to kind of put in, first of all, you need to think about, what am I going to measure? And then you need to think about what you're going to measure and the things that you're going to keep the same. So you need to think about how you're going to record the results depending on what you're measuring. So you need to have some kind of a table or a way to gather your data. And then how will you present the results? So for example, after you've gathered up all your results, how are you going to present it so that when somebody's reading the results of your investigation, it helps them to make sense of it. So for example, you can take the data that you've gathered and you can create something like a bar chart, for example, to show how you are, like the data or the results from your investigation. So these are the kind of general steps that you would go through when you're planning an investigation or coming up with a strategy to test your hypothesis. So this here is a nice example of an investigation. So in this one, the question, okay, so we're putting the question in here first. So how does temperature affect the growth of mold on bread? So if we think of a piece of bread, for example, and if you leave it out on the table for long enough, what will happen is you'll get microorganisms like mold will start to grow on it, and you can visibly see them on it. So for example, when bread goes blue mold, so you get this growth of mold on it. So we want to, a question could be, how does temperature affect the growth of mold on bread? So pause the video and think about that for a second without looking at the investigation. Like, how would you go about carrying out that investigation? So this student here has taken this question and they have turned it into a hypothesis. So they've changed it into an if-then statement. So if the temperature is lower, then the mold grows more slowly. So this is a prediction that they're making. So the prediction then that they're making is that less mold will grow on a piece of bread that is left in the fridge compared with a piece of bread that is left near a radiator. And that makes sense. Like, that's a sensible prediction. So for example, you can put bread in the refrigerator to keep it fresh for longer. If you leave bread out all night, for example, you leave it there in a warm place, you're given perfect conditions for mold to start to grow on it as well. So they've taken the question, they've turned it into an if-then statement, and they've made a prediction. So the next piece then is, what are you going to change? Okay, so in this, they're going to change the temperature. So this is the fridge and this is the radiator. So they're going to have one piece of bread is going to be in the fridge, and another piece of bread is going to be left near a radiator. So these are the things that they're going to change. So essentially, what are they going to change? They're going to change the temperature. What are you going to measure? So they're going to measure the amount of mold on the bread. So they could measure the temperature as well. Okay, so this is going to be hot and this is going to be cooler. But what they're actually going to measure is they're going to count the number of mold that's growing on the bread. So what are you going to keep the same? So some of the things that they're going to keep the same, they're going to use the same type of bread for the experiment. They're going to carry out the test at the same time in the day. They're going to carry out the test at night, during the day and at night. So what they're going to do is they're going to leave the bread in the places for the same amount of time. So for example, they're going to keep the bread in the fridge and one piece by the radiator for the same amount of time, and they're going to keep both of them in the dark as well. Okay, so they're going to keep both pieces of bread in the dark as well. So that's something that they're going to keep the same for the experiment. So those are the time they're going to leave them for. Both of them are going to be kept in the dark, and they're going to use the same type of bread. These are things that they're going to keep the same in the experiment. So then you can see here, they've just simply listed out the things that they need for the experiment. So they need 2 pieces of bread, 2 plastic covers that they need in order to keep the bread in. They need like a marker. They need obviously a fridge and a radiator, and I would say as well they could measure the temperature, and so they might use a thermometer as well. And notice here that they've kind of put in a labeled diagram of the things that they're going to use in their experiment. And then what they've done is they've come up with a method. So this is their method here. So put each piece of bread inside a plastic bag, zip up the bags, label each bag with a marker, put one bag in the refrigerator, put one bag in a warm place in the dark, near a radiator for example. Check on the bags every day and draw pictures of what you see. So this is how they're going to present the results. And do not open the bags and put them in the trash after 1 week. So that's kind of some safety that they're taking into account, and compare the results from the two pieces of bread. So when they carry out their analysis, they can compare and then they can go back and answer their questions. So that's really looking at like questions that are suitable for science, and then how to go about evaluating and coming up with ways to test your questions as well. So hopefully that makes sense, and we will go about and create an experiment to do something similar to this as well. Okay, thank you.